What's up guys, it's Brad from LightArchitect here. In this video, I'm going to be doing a 3D scene and compositing walkthrough of our recently uploaded dome destruction live action visual effects shot inside of Blender. As usual, this scene walkthrough is not really a tutorial, but should give you some ideas on how you can create some interesting destruction scenes like this in your own projects. Anyways guys, let's get started. Here we are inside of Blender. The first thing I did to create this shot was, of course, 3D track our live action footage. So as you can see here in the motion tracking tab, I have a variety of tracking points here, and I've just gone through the footage and tracked a variety of points to give that information to Blender in order to reconstruct the movement of the live action camera inside of the computer. And as I mentioned in previous videos, I have a tutorial on how to 3D track your footage and add CG elements to that. So I'll put a link to that in the description below if you're interested in this process, as it is a really important step that you need to know in order to composite CG with live action. But anyways, just on a very basic 3D track here, got a solve error of under 1 pixel, so went with that, and yeah, imported this tracking data into the virtual camera inside of Blender here. And before I actually shattered and did any simulation on some of these elements here, I used the tracking points in 3D space here to sort of reconstruct the general environment of our live action shot in the computer. So as you can see, if I go to camera view, you can kind of see what's happening here. So I've just used, little points like this to line up the main ground plane of our scene here, and then also, the main dome where it's extended here. So these tracking points are actually really helpful in actually making sure that your CG object that you're adding to your scene is in the right portion of 3D space inside of the computer, so that as your camera, moves through the shot, it's going to stay where it's desired. So anyways, I reconstructed the general geometry of the scene. I added this ground plane here with the general shape of our live action environment. And then I also wanted to, add a little bit more to the scene as well. So the first thing I knew I wanted to add was this dome here. So before I actually fractured it, I just added if I can find it here, just a very basic dome. And this was before I actually fractured anything. So that was the first thing I did. It's just a simple sphere that I cut in half and deleted the bottom vertices from, and then I eventually extruded that and made it a more solid object so that we could fracture it and give it that destruction. So I've added that dome to our scene, and then I also wanted to add a little bit more to the shot. So what I've done is I've added a few different pipe assets here, and these are actually from our City Builder 3D asset-based add-on. I just used the pipes asset, so I just imported that into the scene and placed it accordingly inside of the 3D world. So I just duplicated that a few times to kind of populate the space before we got to the actual dome here. And I've done the same thing with these walkways. I've just imported that into the scene. These walkways are actually a piece from City Builder 3D as well. I just took one of the walkways from the top of one of our buildings and isolated it, and then added an array modifier to it in order to extend where it's going here. So you can see if I bring this down, just using that array modifier to, duplicate it over and over again until I got the desired length that I wanted. As I mentioned in a previous video, I also needed something to hide the seam where the CG dome ended and the live action dome begins. One of the trickiest parts in combining CG with live action is hiding that seam where the CG starts and the live action begins. And obviously there isn't actually a dome in this shot. We were just extending this dam that was already there. So I added that walkway along the seam of where the dome begins and where this live action dam ends. And that was just to help integrate the CG into the live action a bit more by just hiding that seam in the geometry there. So that was one of the reasons why we added the walkways in the first place. In addition to this circular part of the walkway, I just decided to add these arrays as well. So I also duplicated the ground plane here, as you can see in this object right here, and I just added a very basic subdivision and wireframe modifier on it to just give a little extra detail in the scene. So essentially what we've done here is just duplicated the base environment geometry and then added a wireframe modifier to that geometry and just kind of extended it up into the dome here. And that wireframe modifier, as you can see here, let's see if I can isolate it by itself really quick. So as you can see, those kind of detailing pipes overlaid on top of our environment, just that duplicate geometry of kind of our landscape projection there. And I just added a very basic wireframe modifier to this geometry to just, you know, add a little bit of detailing on the top of it and just give a little bit more interesting result. I'm not sure we really needed it. However, it's a nice touch. And I saw this in some other visual effects breakdowns recently, so I thought I'd try it out to see how it went. And I'm not unhappy with the result. But anyways, after reconstructing the geometry, it was time to shatter and simulate the collapse of the dome here. All I've done here is cut out a portion of the dome, and I just used an icosphere and then utilized our cut to objects button under KHAOS destruction tools and cut out this portion of our dome here. And then after cutting out this portion, I drew a fracture place with the annotation tool and then utilized the self fracture settings that we've conveniently added in our KHAOS tab here to fracture it from the drawing. I used a source limit of 400 and you know, just shattered this portion of the dome here. And then finally, after shattering it, I turned all of these objects into rigid bodies and then animated this icosphere hitting into them. So as you can see, if I just play through our scene really quick, but you can see the icosphere hits the middle of our destroyed dome here, and the dome starts kind of collapsing in on itself. And the reason it's going so slowly is just because I've also added some constraints with KHAOS as well, so that the outer parts of our fractured dome here kind of stay constrained more than the inner parts. So you can see kind of the constraints breaking over time, and then eventually these guys start breaking as well when their threshold is reached. So on the other side here, you can see the various constraints that I've added under KHAOS-001 collection. And I'll go ahead and go under KHAOS. I believe it's under KHAOS-001. You can see our constraints here. I've just added one constraint system, mostly just holding together these outer pieces of our destroyed dome here. So a super simple setup. You can see that they are not breakable constraints here with a threshold of 10. So that's just going to kind of hold the outer edges of our collapsing dome here in place and make it collapse much slower. And I found that adding those constraints tend to be the way to get a more organic, destructive result rather than just creating rigid bodies for all of these objects and having them all loosely collapse in on each other. It's a lot better to add some constraints. So you can definitely make this more complicated. You can add a lot more constraints and organize them within the KHAOS add-on here and select them all through the drop-down menu. As you can see, we only have one here right now, but if you wanted to add a bunch of different constraint systems here, it'd be very easy to just select the objects that you want to kind of constrain together and then, you know, create that constraint and then select which one you want to edit at any given moment and, you know, make them breakable or change the threshold, however you want to do it, and give your own unique result to the simulation. But anyways, after fracturing and creating this rigid body simulation, it was time to add some debris on top of our original rigid body simulation. And as I mentioned before, in my opinion, this is one of the best ways you can add some more realism to your simulation. A lot of the time, it's not enough to just have a rigid body simulation. You need to have that small scale debris that's sort of emitted from the rigid bodies themselves to kind of fill in the rest of the rubble and give it a little bit more of a detailed look for your destruction. So what I've done here, I'll go ahead and select all of our rigid bodies. So these are all the rigid bodies in our simulation. And also, I forgot to mention, this dome is a passive rigid body, meaning that all of our active rigid bodies will interact with it, but it doesn't have the forces of gravity and everything interacting with it. So it's just kind of static within the scene, but all of the other rigid bodies will interact with it. But anyways, after creating the rigid body simulation, it was time to add that small scale debris. So on the frame where the icosphere hits the rigid bodies, around frame 319. You can see that in our particle settings tab, we have a rock particle explosion occurring, and it's turned off right now for viewport reasons. So I'll go ahead and enable it. So as you can see here, I have the viewport display turned down quite a bit, but there's a little bit of small scale debris coming off of our rigid bodies. And some of you noticed in the visual effects breakdown video that I did use children particles. So each one of these particles here actually has 20 particles around it, which gives it a much denser looking small scale scale debris look. However, it's not quite as accurate as just cranking up the number of particles, but my computer was starting to lag pretty heavily there. I don't have a maxed out machine right now, so I just decided to use the simple children here. And just for the sake of showing you guys what it looks like with all of those children enabled, go ahead and turn up the display amount here to 20. So here you can see all of that small scale detail that the debris simulation adds with these particles. I'll bring that back down to 1 now since my computer's starting to lag, but it was rendered out with 20 children for every single particle here. And to add these small scale debris particles, I've just used the rocks checkbox here under the KHAOS tab. And as I've shown in some previous videos, to add that small scale debris, I've just selected all of our rigid bodies at that specific moment in the simulation where I wanted the small scale debris to emit from. And I've just checked the rocks checkbox and then added that destruction tool debris with this button right here. So as soon as that was selected, all of that debris would be emitted at that moment in the timeline for a few frames forward. And then of course, to adjust this particle simulation, you can just go to the particle tab with one of those rigid bodies selected, and you can adjust the number of particles, you can adjust the lifetime, the frame start and frame end, all the other particle settings that you'd like to adjust depending on the look you're going for. But adding small scale debris just through the button without adjusting any of the particle system settings should give you a pretty good result right off the bat. So anyways, that was the next step here. I just added that small scale particle debris with the rocks checkbox. And after adding the rocks small scale debris, another thing I added to bring the destruction into the scene even more is some dust atmospheres. So one of the things I've noticed when creating destruction simulations is that it's really nice to work from large scale detail all the way down to the smallest detail. So for example, first we created the rigid body simulation, and then after that, as we just mentioned, we've created the particle debris for those smaller rocks. And then finally, I added these dust atmospheres. So as you can see, if I turn them on, actually, I'll go ahead and go to their view layer here. If I go to our rendered view, you can see that I've imported some atmosphere stock elements on top of our dam here. And I've just used import images as planes and imported them as a video, and then kind of placed them within the rigid body simulation, and then use the rigid body simulation as a holdout so that it would kind of interact in the 3D world here. So you can see kind of the wireframe modifier on the dome there. And even though this is a 2D element, I've layered a few of them in different areas of Z space in order to get a little bit more of a 3D look. And since the camera is pushing in on them and it's not kind of rotating around them, the 2D element is pretty effectively hidden in the 3D world and looks pretty nice. But anyways, just added a nice little 2D atmosphere to the scene there, duplicated a few times and offset the animation so that as that dam starts to collapse, that dust kind of fades into the shot. And you can see that I've also made the particle system a holdout as well, so that integrates that dust into the environment even better. And I forgot to mention that I did duplicate the dome here and then add a wireframe modifier on top of it as well, just to add a little bit more detail on top of the dome. And then once the dome is actually fractured here, that wireframe modifier still stays, which kind of gives the impression that maybe some of the structural points are still kind of intact as the rest of the dome is collapsing. So just the same technique that I used on the foreground environment here with the wireframe modifier, I've done the same thing by just duplicating the dome here and adding a wireframe modifier there as well. So a little tip to add some nice detail to your scenes. Finally, after creating all of this destruction, I separated all of our different elements into their own specific view layers. So what I've done here is I have 5 different view layers, each with their own separate elements on them. So for example, the first one is just our foreground walkways and pipes. So as you can see here in this setup, everything other than the foreground walkways and pipes here is selected to affect only the scene indirectly with the indirect only option here. So you can see that if I go to render view on this view layer, for example, you can see that we're only getting this foreground detail in this view layer. So this helps us overlay our elements much easier in our composite because we have a lot more control over each specific view layer. So I've done this for all of the different passes that I want. The first one was our foreground walkways and pipes. So I've done that for the first view layer. Then under the second one, we have our background shadow. So for this one, I believe it's just our rough environment model here that we've created, and we've enabled indirect only on everything else, and then turned this environmental ground plane into a shadow catcher so that now, as you can see, we're getting the shadows rendered on this view layer, but nothing else. And you can see that there are some fairly prevalent shadows where the pipes go into the dam here. So that was our next view layer. Again, just keeping everything else except the object I want rendered selected as indirect only, so it's only affecting the lighting of the scene. Our next view layer was the reflection view layer. So this is kind of similar to the shadow catcher view layer. I just duplicated the topology of our environment and then made it a super reflective material. And then, as I mentioned before, everything else is under indirect only. So we're still getting some reflections, as you can see, of the pipes here, as well as some shadows. I guess I also enabled the shadow catcher on this material. So we're getting the reflections of the pipes, as well as, if the camera angle can see it, whenever the dome reflects against this, we'll also see that as well. So I wanted to have some reflections of our different elements here on this view layer. So I use that as a compositing layer as well. And then finally, we have our fractured dome view layer. So as you can see here, everything is under indirect only for this view layer, except for the fractured dome. And you would see the particles here as well. However, I'm just going to leave them off for now since it slows down our viewport so much, but we would see the particles there as well. And then finally, our last view layer was our dust atmospheres, which is the one I just showed you previously, where we have these 2D elements in Z space, just kind of filling in that small scale detail after the rigid body simulation and debris. So anyways, after separating these into their own specific view layers, I made sure that I checked each of the passes and the data that I wanted to use for each view layer. And then I actually wanted to export all of these different view layers into one multi-layer OpenEXR sequence so that we have all of our view layers in one specific file type so we can composite everything together fairly effectively. So if you don't know what multi-layer EXR is, I do have a video on it, but essentially it's going to pack all of your passes and all of your view layers into one output so that you don't have to mess around with a whole bunch of different PNG sequences in your compositing process. But yeah, after testing out a few renders, I exported at 1920 by 1080p resolution, 100%. As I mentioned, I used the OpenEXR multi-layer file format, rendered out the sequence, and then eventually got into compositing inside of Blender in a separate file, which I will go through here next. Alright guys, so for this project, I decided to composite entirely inside of Blender using a node compositing setup, and as you can see here, this is our final node tree, and it's not super complex. However, if you're not used to node compositing, this may look a little bit complicated, but essentially what I did is just like in a layer-based compositing program, just kind of overlay different elements on top of each other and combine them in order to get our final result. But as I mentioned, I did export this as a multi-layer OpenEXR sequence, so in order to understand that, as you can see here, this is our image sequence imported with that OpenEXR file. And as you can see here, you can essentially just change the view layer in the same file in order to get different outputs for this specific node. And then if you, for example, select the background shadow view layer, if you had an ambient occlusion pass enabled for that view layer, you would also get separate output nodes for that data. So multi-layer OpenEXR file sequence is definitely the way to go when it comes to complex compositing. But I thought I'd just share that with you guys. Anyways, I'll go through this compositing setup fairly quickly here. As you can see, the first node that we have in our tree is our movie clip. So I've added that one to our scene. And then the first thing that I overlaid was our reflection pass of our water. So you can see it right here. And I've just overlaid that on top of our movie clip. So as you can see, I'll just add another view node here so we can see this portion of the timeline. So this is what our composite looks like after we combine our reflection with our movie clip. And you can see that I've run our reflection pass through a bokeh blur node as well as an RGB curves node to brighten it up a bit. But essentially what this is doing is it's creating those reflections on our water here. And you can see the reflections of the pipes here if you look closely. And I'll go ahead and turn it off really quick just to see it before. There's before, and then here's after once we add those reflections. So that was the first pass we added. I added a little bit of blur to kind of blend it into the shot. You can see that it's not blending in perfectly here, but once all of those other elements are added on top of it, it looks pretty good. So the next layer that I added was our background shadow pass here. So you can see right here, it's just all of our shadows of our pipes and everything. And I just overlaid this on top of our reflection after adding some blur to it as well. And you can use blur to hide artifacts as well as match the general sharpness of your live action shot. So that's what I've done here, just 2 pixel blur on the X and Y axis. And again, I'll just connect our viewer here after this node. So here we are with the shadow pass enabled. You can see the shadows on our side of the dam here. And I've used an alpha over node this time as opposed to an overlay node, but this is just a standard alpha over node, just overlaying that directly on top of our shot. And you can see this without the shadow, and then turning that factor all the way to 1 to see it with the shadow. All right, so after adding our shadows, I've overlaid our dome destruction element. You can see same OpenEXR sequence, just selected the dome fractured view layer. I've also exported an ambient occlusion pass with this view layer so we could add a little bit more shadows to this element. So I've taken our dome destruction, I've run it through a blur as well as an RGB curves node to kind of bring it down a bit. And then I've used a mask in order to kind of feather in the edges a bit. So I've actually created a mask in the mask tab in order to kind of just feather in the edges in case there is a little bit of overlapping. So yeah, I've just keyframed that mask and then input that into a set alpha node to affect our dome destruction layer. And then finally just use an alpha overlayer here. So let's go ahead and add our viewer at the end of this. This is what we have so far. And you can see even without the blur and the RGB curves, what it's looking like. Not totally blended into our environment yet, but you know, once this is added, you know, that already helps a little bit. And we're just matching those shadow levels pretty closely. It's not totally accurate yet, but once everything is overlaid on top of it, it looks pretty good. So yeah, we added that fractured dome element. Then finally, after that fractured dome element, we've added our foreground pipes. So you can see that here. And again, use some ambient occlusion on this one as well and run it through an RGB curves and blur node to blend it into our shot. And let's go ahead and add the viewer over here. So here's our shot with our foreground elements overlaid with our pipes and walkways and everything. And this is what I talked about in a previous video about hiding the seams where your CG element starts and your live action element begins. As you can see, without these overlaid foreground elements, you would have to be a lot more precise about how you line up this dome here. But once you add these foreground elements, it you know, hides that actual seam, which helps blend it into the shot with a little bit more ease. So yeah, after adding our foreground elements here, our final view layer that we added on top of everything was our dust atmospheres view layer. I've just run this through an alpha over node. And you can see that I've actually keyframed the alpha over node so that more of the dust view layer kind of fades in over time. Super simple setup here. This is our final composite without color correction. I did actually end up adding a little bit of haze in the foreground as well for the final composite. That's not actually shown here, but I did add a little bit of atmospheres in the foreground as well to kind of just have a little bit more of a interesting look to the shot. But yeah, this is our final result before color correction, and I'm pretty happy with the result. I think in the future I would have added a bit more small scale detail with our rigid bodies, and if I had a little bit more powerful computer, I definitely wouldn't have used the children debris particles. But for doing this shot in just around a day, I'm pretty happy with this result. I hope you enjoyed this breakdown. As always, feel free to leave a comment if you have any questions or suggestions in the comment section below. Let us know what you'd like to see next on this channel, what other visual effects techniques you'd like to learn, and I will see you in the next video.